Okay, so get this. We're going to Io today, Jupiter's moon.
Oh, wow.
Yeah. And you better pack some serious sunscreen because this place is a volcanic inferno.
You're not kidding, are you?
Nope. It's like constantly erupting with these massive volcanoes practically spitting lava into space.
Sounds intense.
It is. And we're going to
Ugh.
figure out why. Welcome to Cosmos in a Pod, Space and Astronomy series.
All right, I'm ready to dive in. And Io is just one of those places that makes you just completely rethink what's even possible out there in the universe.
Yeah, it really makes you wonder.
Yeah.
So before we get into like all the fiery details, can we get a quick snapshot? What is Io? How big are we talking?
So think of our own moon,
Okay.
but just a bit bigger.
All right. Okay.
That's Io. It's not the largest moon out there, but it's definitely got the most personality.
Okay. So I'm picturing a slightly larger moon, but
Yeah.
instead of like peaceful craters, it's just constant fireworks. What is causing all this volcanic mayhem?
It's a phenomenon called tidal heating.
Okay.
And it's basically a cosmic tug-of-war. So Io gets caught between this gravitational pull of Jupiter on one side and then two of its other moons on the other side, Europa and Ganymede.
So it's like being pulled in three different directions.
Exactly. Imagine being constantly squeezed and stretched, like a stress ball.
Oh man, that sounds uncomfortable.
That's Io's daily life.
Oh my goodness. So
That's-
all this squeezing and stretching, it's making Io's inside super hot, right?
Exactly. It's like constantly kneading dough.
Okay.
All that friction is going to keep Io's interior molten, and all that molten rock needs to escape somewhere,
Oh, I see.
which is why we see these incredible eruptions.
Okay, so how do Io's volcanoes compare to what we see on Earth? Are we talking like Mount Vesuvius or something way more intense?
Way more intense.
thinking-
We're talking hundreds of active volcanoes.
Hundreds.
Yeah, some spewing lava fountains that are hundreds of kilometers high.
Oh my goodness.
And there's one called Pele that's especially famous.
Pele. Okay.
Yeah, for putting on these just spectacular shows.
So what's the lava like on Io? Is it the same stuff we have here?
It is lava, but it's not like the kind we're used to.
Okay.
Io's lava is made of silicate rock, just like on Earth.
Uh-huh.
But it's much hotter. We're talking temperatures that would just melt most metals.
Wow.
And because it's so hot, it actually flows much faster.
Okay.
And it creates these crazy alien landscapes.
So not your average Hawaiian lava flow then?
Definitely not.
So with all this molten rock like spewing everywhere, what does Io's surface actually look like?
Okay, so imagine a painter's palette gone wild.
Right.
Seriously. Io's surface is this constantly changing mix of yellows and oranges, reds and whites.
Like a rainbow?
Yeah, and all those colors actually come from sulfur and sulfur dioxide,
Oh, interesting.
which are constantly being deposited by the volcanic eruptions.
No craters here. Io's surface is way too active for those to form.
Wow.
It's constantly being reshaped by these lava flows and volcanic plumes and sulfur deposits.
Okay, so we've got this super hot, constantly erupting moon.
But what about an atmosphere? Can anything survive in that kind of environment?
Well, Io does have an atmosphere,
Okay.
but it's incredibly thin and it's toxic to us Earthlings.
Yeah.
It's mostly made up of sulfur dioxide,
Okay.
which, you guessed it, is constantly being replenished by those volcanic eruptions.
Oh, wow. So every time it erupts, it's adding to its poisonous atmosphere.
Yeah, basically. Not very hospitable.
No, not at all. But here's where things get even more interesting. All this volcanic activity isn't just affecting Io itself. It's actually having a huge impact on Jupiter.
That's right.
Hold on. This tiny moon is messing with the biggest planet in our solar system. How is that even possible?
So you see, all those eruptions are spewing out tons of particles that get caught up in Jupiter's magnetic field, which is incredibly powerful. And guess what that creates?
I'm on the edge of my seat. What does it create?
It creates this giant ring of charged particles around Jupiter. It's called a plasma torus.
Oh, wow.
It's like a giant glowing donut.
A glowing donut?
It's one of the most spectacular sights in our solar system.
A glowing donut of charged particles, Io, is way more powerful than its size suggests.
Yeah, it really is. It's a testament to how even small objects can have a big impact in the universe.
I need a moment to process this glowing space donut situation. But before I do, how did we figure all this out about Io? I mean, did Galileo just look up and see volcanoes erupting?
That would have been incredible.
Right.
But no. When Galileo first spotted Io with his telescope back in 1610, it just looked like a bright dot. He had no idea what a wild place it really was.
So when did we start realizing that Io was a volcanic wonderland?
It wasn't until the Voyager 1 and 2 missions
Okay.
in the late 1970s
Uh-huh.
that we got our first real glimpse of its volcanic activity.
I can only imagine the shock. It must have been like a pretty big deal for the scientific community.
It was a revolutionary discovery. It was the first place beyond Earth where we observed active volcanoes.
Wow.
And it completely changed our understanding of what was even possible out there.
Okay, so Voyager gives us a sneak peek, but I'm guessing the story doesn't end there. What happened next?
Well,
we needed a closer look, right?
Yeah.
So in the 1990s, NASA sent the Galileo spacecraft to orbit Jupiter and get a really good look at its moons.
All right, and what did Galileo teach us about this fiery moon?
Oh, it was a game changer. Galileo gave us high-resolution images of Io's surface,
Okay.
mapped its volcanoes,
Wow.
and even measured the composition of its volcanic plumes.
So thanks to Galileo, we started to see Io in all its fiery glory, craters and all.
Actually, no craters. Remember, Io's surface is constantly being reshaped by the volcanic activity.
That's right. I keep forgetting. It's way too dynamic
It is.
for impact craters to stick around very long. So we have Voyager's first look, then Galileo providing incredible detail. Did any other missions visit Io?
We didn't stop there. The New Horizons spacecraft on its way to Pluto
Oh, right.
actually swung by Jupiter
Uh-huh.
and captured some stunning images of Io's volcanic plumes back in 2007.
Nice.
And even today, the Juno spacecraft, which is orbiting Jupiter,
Is collecting valuable data about Io's magnetic field and its interaction with the giant planet.
wow. So we've gone from this tiny dot in Galileo's telescope to having multiple spacecraft studying this crazy moon. It's incredible how far we've come in just a few centuries.
It's a real testament to human curiosity. We just keep pushing the boundaries of what we know. And Io is just one of those places that keeps on giving.
But even with all we've learned, I'm guessing there are still mysteries about Io that have scientists scratching their heads.
Wow, absolutely. We've only just scratched the surface, so to speak.
Okay.
There's so much more we want to know about this intriguing moon.
Like what? Give me some juicy Io mysteries that are keeping scientists up at night.
Well, for one, we're still not entirely sure about the exact composition of Io's mantle. What's down there deep beneath the surface that's fueling all this volcanic activity for billions of years?
Yeah.
It's a puzzle we're still trying to solve.
It's like knowing there's a fire but not being sure what's burning right.
Exactly.
Yeah.
And then there's the question of volcanic variability. Why are some of Io's volcanoes more active than others? What triggers these massive eruptions?
Right.
There's a whole lot going on beneath Io's surface that we just don't fully understand.
It sounds like Io is this giant volcanic puzzle box, and we're just starting to figure out how to open it.
That's a great way to put it. And that's what makes it so fascinating. Io keeps us guessing. And that's what drives us to keep exploring.
I can't wait to uncover more of Io's secrets. But first, I think we need to take a little break to let all this information sink in.
Let's do that. I'm sure you have plenty more questions for me when we come back. So before the break, we were talking about how this tiny moon, Io, is actually having a huge impact on Jupiter itself.
Right. That giant glowing space donut you mentioned, the plasma torus. It's mind-boggling to think that a moon could create something that massive around a planet.
It really is. And it all comes down to Io's incredible volcanic activity.
Right.
So all those eruptions, they're spewing out tons of these charged particles,
Okay.
and they get swept up in Jupiter's magnetic field, which is incredibly powerful.
So Jupiter's magnetic field is basically acting like this giant cosmic vacuum cleaner, sucking up all those particles from Io.
That's a great analogy.
Great.
And as those particles get trapped in the magnetic field, they form this ring, this torus, around Jupiter.
Uh-huh.
And it's constantly being fed by Io's volcanic plumes.
Oh, wow.
So it's a very dynamic structure.
So it's like this never-ending cosmic fountain with Io, like, providing the water.
I did.
And then Jupiter's magnetic field shaping the flow.
Exactly. And it's not just a pretty sight either. This plasma torus actually has a significant impact on Jupiter's magnetic field. It distorts it and stretches it in some pretty fascinating ways.
So Io's basically giving Jupiter a magnetic makeover.
You could say that.
What kind of effects does that have?
Well, one of the most noticeable effects is on Jupiter's auroras. You know those incredible light shows we see near Jupiter's poles?
Yeah, they're like the Northern Lights on steroids.
Exactly.
So Io's actually contributing to those.
It's a key player. The particles from Io's plasma torus, they interact with Jupiter's atmosphere, and that creates those stunning auroral displays.
So Io's not just a volcanic moon, it's like a cosmic artist, too.
That's one way to put it.
But its influence doesn't stop there, right? You mentioned something before about Io affecting its neighboring moon, Europa.
That's right. Remember, Io is caught in this gravitational tug-of-war
Right.
with Jupiter and its other moons.
Uh-huh.
And that tug-of-war actually has some interesting effects on Europa, which is thought to have a vast liquid ocean beneath its icy surface.
Wait, a liquid ocean? Under all that ice, how is that even possible so far from the sun?
It's thanks to those same tidal forces that cause Eo's volcanic activity.
Yeah.
So the gravitational pull from Jupiter and its moons, it stretches and squeezes Europa, and that generates heat inside. And that heat is what keeps the ocean liquid, even though it's so far from the sun.
So in a way, Io is responsible for keeping Europa's ocean from, like, freezing solid.
You could say that.
That's incredible.
It really is. It's another example of just how interconnected everything is in the Jupiter system.
Yeah.
And it raises some really intriguing possibilities. We know that life, as we understand it, needs liquid water.
Right.
And if Europa has a vast salty ocean, well, who knows what might be lurking down there.
Whoa, that's a mind-blowing thought. This fiery volcanic moon might actually be helping to create conditions for life on another moon.
Yeah, it's some serious cosmic irony.
It really is. It just goes to show you that the universe is full of surprises.
Yeah.
And it highlights how much we still have to learn.
It really does.
Speaking of learning, you mentioned earlier that there are still a lot of mysteries surrounding Io. What are some of the big questions that scientists are trying to answer right now?
Well, one of the biggest puzzles is the exact composition of Io's mantle. We know it's molten.
Right.
We know it's driving all that volcanic activity.
Yeah.
But what's it actually made of? What's the recipe for this incredible internal heat engine?
It's like having this amazing machine, but not knowing what's going on under the hood.
Yeah, exactly. And then there's the question of why some of UA's volcanoes are so much more violent than others. What are the factors that control the intensity and frequency of these eruptions?
Right.
Is it the composition of the magma? Is it the depth of the magma chamber? We're still trying to figure all of that out.
It's like each volcano has its own personality, and we're trying to, like, get to know them all.
That's a great way to think about it. And then there's this bigger question of how Io has managed to sustain this level of volcanic activity for billions of years. What's keeping it from cooling down? Is there something replenishing the heat in its interior?
It seems like every answer we get about Io just leads to more questions. It's a cosmic mystery wrapped in an enigma.
You got it. And that's what makes it so captivating for scientists. We're driven by this curiosity, by this desire to understand the how and the why of things. And Io is a perfect example of a place that just begs to be explored further.
So how do we go about answering these questions? What kind of missions are on the horizon that could help us unlock Io's secrets?
Well, there are a few exciting possibilities. NASA's Juno spacecraft, which is currently orbiting Jupiter.
Right.
It's already made some observations of Io.
Oh, cool.
It's not a dedicated Io mission,
Right.
but it's giving us some valuable data about Io's magnetic field and its interaction with Jupiter.
So it's like getting bonus information from a mission that's already out there.
Exactly.
That's pretty cool.
But what we really need is a dedicated mission to Io,
Okay.
one that can orbit the moon and study it in detail.
Yeah.
There have been several mission concepts proposed over the years, and there's definitely a growing interest in the scientific community to make this happen.
Yeah, I can imagine a dedicated Io mission would be incredible. What kind of data could we collect with a mission like that?
Well, we could map Io's surface in unprecedented detail. We could study the composition of its volcanic plumes, and we could even track the changes in its volcanic activity over time.
Wow.
We could also get a much clearer picture of its interior structure and the processes that drive its volcanism.
It sounds like a mission that could rewrite the textbooks on Io.
It has the potential to be a real game changer. And not just for our understanding of Io, but also for our understanding of volcanic processes on other worlds, both in our solar system and beyond.
I'm definitely keeping my fingers crossed that a dedicated Io mission gets the green light. It'd be amazing to see what we could learn. But in the meantime, what can we do to keep exploring this fascinating moon from afar?
While there are some incredible images and data available online from previous missions,
Oh, cool.
you can explore Io virtually from the comfort of your own home.
Awesome.
And of course, keep following the latest news and research coming from the scientists that are studying Io.
Okay.
There are always new discoveries being made.
It's inspiring to think about all the secrets that are still waiting to be uncovered.
And that's the beauty of space exploration, isn't it? There's always something new to discover, something that will challenge our understanding and push us to ask more questions.
Well, I'm definitely ready to dive into more of those questions. But before we do, I think we need to take another quick break. When we come back, let's talk about the bigger picture. What does Io teach us about the universe? And what are the implications of its discoveries for our search for life beyond Earth?
I'm ready to explore those big questions when we return. Welcome back to Cosmos in a Pod. Before the break, we were just starting to touch on some of the bigger questions that Io raises.
Right, we've explored like the volcanoes and the crazy surface and the impact on Jupiter. But what does it all mean? What does Io teach us about the universe beyond our own planet?
Well, for me, one of the biggest takeaways is that the universe is a much more dynamic and interconnected place than we ever imagined.
Okay, unpack that a bit.
Yeah.
What do you mean by dynamic and interconnected?
Okay, so think about it. For centuries, we humans, we looked up at the stars and saw these seemingly unchanging points of light.
Yeah,
And we thought of planets and moons as these static, almost lifeless objects.
right.
But Io throws all that out the window.
Yeah, it's definitely not static. It's like a giant volcanic fireworks show that never ends.
Exactly. And that constant activity, that dynamism, it tells us that the universe is in constant motion. It's constantly evolving. It's not this static picture that we once thought it was.
So Io is like a cosmic wake-up call, telling us to rethink our assumptions about how the universe works.
Precisely. And it's not just about dynamism either. Remember how we talked about Io's influence on Jupiter and its other moons? It's not just this isolated little world doing its own thing.
Right, it's creating that plasma torus around Jupiter. And it's potentially helping to keep Europa's ocean liquid. It's got its fiery fingers and a lot of cosmic pies.
That's a great way to put it. And that interconnectedness is a crucial concept in astronomy. It reminds us that we can't just study objects in isolation. We have to consider their relationships, their interactions, to truly understand how they work.
So Io is like a poster child for cosmic interconnectedness.
I'd say so. And that brings us to perhaps the most profound implication of Io's discoveries. Its potential role in creating conditions for life on Europa.
Right. We talked about how those tidal forces, the same ones that are making Euro erupt, could be keeping Europa's ocean liquid. It's mind-boggling to think that this fiery volcanic moon might indirectly be helping to create an environment where life could exist.
Yeah, it really challenges our assumptions about what a habitable world might look like. For a long time, we focused on finding planets that were just the right distance from their stars. You know, in that so-called Goldilocks zone
Right.
where liquid water could exist on the surface.
But Europa is showing us that habitability might not be so simple, that life could find a way even in these seemingly extreme environments.
Exactly. It's expanding our definition of what's possible, and it's giving us new hope in our search for life beyond Earth. Maybe we don't need to limit ourselves to those perfect Earth-like planets. Maybe life is more resilient, more adaptable than we thought.
It's a humbling and exciting thought, and it makes you wonder what other surprises are out there just waiting to be discovered.
That's the beauty of space exploration, isn't it? Every time we think we have it figured out, the universe throws us a curveball, something like Io, that makes us rethink everything.
So what's next? What are the big questions that we still need to answer about Io? And how do we go about answering them?
Well, there's still so much we don't know about Io's interior. What's the exact composition of its mantle? How is it generating so much heat? And what are the long-term implications of all that volcanic activity?
It sounds like we need to send a dedicated mission to Io, something that can really dive deep into its secrets.
Absolutely. And thankfully, there are some exciting mission concepts being developed right now. One proposal involves a spacecraft that would orbit Io for several years,
Wow.
mapping its surface, studying its volcanoes, and even collecting samples of its volcanic plumes.
Imagine the data we could get from a mission like that. It would revolutionize our understanding of Io.
It would be a game changer, and it wouldn't just benefit our understanding of Io, it would also provide valuable insights into volcanic processes on other worlds, including Earth.
It's incredible to think that this little moon, orbiting a giant planet billions of miles away, could teach us so much about our own planet.
That's the power of space exploration, isn't it? It broadens our perspective, it challenges our assumptions, and ultimately it helps us to understand our place in the cosmos a little bit better.
Well, I think it's safe to say that Io has left a lasting impression on us today. It's a reminder that the universe is full of wonder and mystery and endless possibilities.
And that the search for knowledge, for understanding, is one of the most rewarding journeys we can undertake.
Well, thank you so much for taking us on this incredible journey to the fiery world of Io. It's been an absolute pleasure.
The pleasure was all mine. And to all our listeners out there, keep exploring, keep asking questions, and never lose your sense of wonder. The universe is waiting to be discovered.
And don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel for more exciting deep dives into the universe. Until next time, keep looking up.